let's now take a look at the Syslog implementation, but before doing so, we just wanted to show you one other way you could run bash shell scripts using cron, and that is to prefix the shell script with the source command or dot. That's nano etc cron tab, the general system-wide cron file, and this is on the remote server. We need to do it locally. And for example, for the ping test, if you prefix the shell script with a dot, that means to source it, or the keyword source. Either or will ensure that the command runs successfully. Ditto for the remote user student1. Let's sun as student1, and then cron tab E, which takes us into VI. We'll re-execute export, then cron tab E again, and change this to source. And we'll check up on the cron item throughout the rest of our studies. So with that said, we need to look at Syslog. Syslog handles logging. And it does so by supporting two facilities, or two protocols: Unix domain sockets via the dev log interface, as well as internet sockets using the UDP protocol, port 514 to be specific. So it handles all of the logging on the system. There is a subsystem, klogd, or kernel logger, which is used exclusively by the kernel to log. But apart from that, the programs on the system will log through Syslog, unless of course the program has its own logging facility, such as Apache and others. But by and large, logging is handled through Syslog. Syslog is implemented on this particular box in Red Hat Enterprise 5 as the sysklogd package. And we can find out more information about the package using the RPM utility locally. And the version will be returned once RPM queries its database of packages. So this is the package. Let's RPM queryless sysklogd. And here are the important items. Since Syslog is responsible for logging information from multiple programs, it has a logrotate entry in the etc logrotate.d entry file, or directory that is. There's a file in there which contains the rules for log rotation. In the next section we look at log rotation, where we'll study this file to see the directives that have been specified. When the system is booted, Syslog starts via the initialization script, syslog, and there's a sysconfig item that you can edit to turn on or off various settings, including the ability to bind to UDP. The primary configuration file, however, is located in etc, and it's called syslog.conf. This file contains the various rules that Syslog uses to route information to different files. There's also the klogd component, which we mentioned, which is used by the kernel to log, exclusively of syslogd, the main binary used to log information, as well as documentation. So the main binary is syslogd. It reads etc syslog.conf. Optional startup information is placed in etc sysconfig syslog. An initialization entry is in init.d, and a logrotate entry is in the logrotate.d directory. So Syslog logs daemon information, but how exactly does it do so? Well, we'll get into that in a second. Let's just list one of the other features. That is the ability to log to local and remote targets. By default, Syslog logs locally to a file usually beneath the var log directory tree, but can optionally log to a remote host running Syslog. using internet sockets. So now back to the primary configuration file, the rules file, etc.syslog.conf. This is the primary file where you spend most of your time. Now we're going to focus on the remote server's syslog conf file because it's pristine. The local server has entries from previous studies. A brief look at syslog.conf will reveal as such. The default settings are in, but we've also got a rule for Linux CBT Deb 2 from our Debian training and other items. So to take advantage of a fresh Red Hat Enterprise 5 syslog configuration file, we're going to work on Linux CBT Serve 4. So let's sun and then nano etc syslog.conf. It's installed by default. Hash marks indicate comments when they begin a line, so this kernel entry is commented. As we've mentioned, kernel logging is handled by the klogd daemon, so there's no need to turn on the facility here unless you need additional information routed elsewhere, apart from the standard kernel output locations. Now, a standard syslog file consists of rules and targets. On the left-hand side, you find rules, one or more. The right-hand side, you find targets. So standard syslog.conf file contains rules and targets. But rules can be further broken down into separate components. And they include the following: facilities and levels. This is the main routing capability of Syslog. Syslog is able to route messages based on facilities and levels. Facilities are tied to applications and or daemons. So we'll just indicate by specifying an arrow that it's tied to application/daemon/ network, device, etc. So a given device, application, or daemon is going to report its information using a facility. A facility provides the general way to route information. All facilities share a set number of levels in common, and they vary the level of severity of the message. So levels correspond to levels of importance, or importance of message. And the importance level ranges from 0 through 7, with 0 meaning debug and 7 meaning emergency. So let's list those levels. Beginning with 7 for an emergency message, followed by 6 for alert messages, which are not as critical as emergency messages, but generally indicates a level of criticality that's worth exploration. The 5th level is critical, followed by error, then warning, notice, informational, and last but not least, debug. So from the perspective of Syslog and Syslog supported applications, they'll use a facility followed by one or more levels. And by one or more, we mean the following. The lower the level number, such as 0 for debug, the more information. So let's just indicate more information. However, as you go up to higher levels, less information. But this does not say that the debug level is more important than the emergency level. Quite the contrary. When you receive emergency or higher level messages, they're more important than general debug level messages. And when configuring Syslog, you should be sure to specify a meaningful level so you don't end up with superfluous information. So for example, it's unideal to log at the debug level unless you're truly debugging. It may be more ideal to log at info, notice, or warning and suppress, as a result, the amount of information that you receive. Now, again, the lower the level that you indicate to log, the more information you'll receive. If you log at debug, you'll receive all messages info and higher. If you log at info, you'll receive all messages info and higher, and right up the chain up to emergency. So if you log at the critical level, you will not see error down to debug, but will see critical up to emergency. And that's how Syslog facilities work. So with that said, let's discuss targets. Targets tend to be the following: file, such as varlog messages; TTY, such as dev console, or even dev TTY1. The dev console will report to all consoles, all connected consoles, as well as remote hosts indicated with the @ symbol and the IP address of the remote host, which provides a means for you to log information across the wire using UDP. So again, let's step back and just imagine how Syslog messages are routed. The daemon receives messages based on facilities. Facilities are tied to applications, daemons, network devices, etc., and there are many facilities. Each facility supports 8 levels, 0 through 7, with 0 meaning more information, 7 meaning less information, but more important information. Once the information has been parsed, it needs to be sent to a target, either a file, a TTY, a remote host. You may optionally send to multiple targets simultaneously by indicating multiple rules, or specifying on the right-hand side of your rule multiple targets separated by commas. You may also specify multiple facilities and levels on the left-hand side by delimiting them by comma, which leads us back to the etc.syslog.conf file. Notice for this first uncommented rule, the facility is undefined, or it's defined as all using a catch-all asterisk, meaning any facility. So asterisk equals catch-all / wildcard to mean any facility or level, depending on where it's specified. In this particular case, star.info means any facility at the info level will ultimately be logged to varlog messages. With the exception of mail-related messages, anything .none means not to log, as well as authprive.none, as well as cron.none. So let's just indicate as well that .none equals rule to exclude, or exclusion rule. When you see .none in a rule, it means to exclude those messages. So if a message comes in at any facility with the exception of mail, which means mail-generated messages, authprive, and cron at the info level, those messages will be sent to varlog messages. Again, back to our levels 0 through 7. If a message comes in at the info level, which is level number 1, it also means all levels 2 through 7 will be recorded. Not debug, however. Just info up through emergency, which is a pretty low level to begin with. This also explains why the varlog messages file tends to be populated with a lot of information, because it expects and logs information from various facilities, minus what we saw, mail, authprive, and cron, at the info level, which is pretty verbose. Let's continue exploring the rules. Now, we did mention that authprive nothing goes to varlog messages, which means if you authenticate using a facility that logs using authprive, such as SSH, don't expect to see the message in varlog messages, at least not on Red Hat Enterprise. However, below we see authprive.star, which means the facility .any level, which means any level from debug through emergency, will end up in varlog secure. So when you do authenticate to this enterprise box, expect to find authentication-related messages in varlog secure, and a separate window will confirm that. Let's navigate to varlog and LSL secure, and there we see the file secure, and if we are root or root equivalent, we will be able to examine the contents. And here we see all of the SSH instances, user deletions, and anything that would make use of the authprive facility. Let's move forward. Messages for mail. If the facility is mail, regardless of the mailer, postfix, QMail, sendmail, and the level is anything, that's what the wildcard means, the message is sent to varlog mail log, and it's synced on disk to improve performance, since mail logs tend to be pretty big. Cron-related items. Whenever jobs are run via cron, cron makes use of the cron facility. It's a reserve facility, and all levels of cron will be logged to varlog cron. Any facility that reports at the emergency level will be sent everywhere, which means everywhere possible, all of the TTYs, as well as all of the possible open log files such as varlog messages and so on. For news, we see UUCP, news, at the critical level and higher, gets logged to varlog spooler. And local 7 is the bootlog route, or router. Now what about various facilities? What facilities are available to us? If you man Syslog, or man syslog.conf, you'll get a sense for the supported facilities and levels. Let's just note that. Man syslog.conf to learn about the supported facilities and levels. So back to our shell window, and you'll see, for example, the following facilities: authprive, auth, cron daemon, kernel, LPR for printing, mail, mark, news, security, which is the same as auth, syslog, user, so on and so forth. When you're logging from a network infrastructure device, chances are you're going to make use of the local facility, for which local 0 through 7 are supported. But from our configuration file, syslog.conf, we know that local 7 is being used. Let's cat the contents of etc syslog.conf once more just to refresh your memory, and you see local 7.star contains boot items. So we really have available to us local 0 through 6 for rerouting, let's say, foreign devices like networking devices. Additionally, the syslog.conf documentation includes the various priorities, which we've described, from debug all the way through emergency, or 0 up through to 8, up to 7, that is, for 8 levels. So there's no need to memorize the different facilities and levels. Here are the actions. This is what we call targets. You can send to a regular file, to a main pipe, to a remote machine using a prefix of @ to a list of logged in users, to dev console we saw above. It's pretty straightforward. On the left-hand side you have your rule, and on the right-hand side you have your target, which your documentation labels slightly differently as actions. So with that said, let us make a modification to our infrastructure device, the Cisco router, to cause it to log to the local system, which will cause us to have to do a couple things. So our first task is to enable logging it will enable UDP logging, which means internet socket logging, for remote Cisco gateway, which is located at the following IP address. This is a multi-step task because first and foremost we need to set up the pristine syslog configuration to listen to UDP port 514. To confirm, we can use netstat NUL grep 514. This reveals UDP 514 listeners, or listeners, since there can only be one listener at a given time to a given socket. So let's try this from the shell to see if it's listening, and there you see grep returned nothing. And a netstat NUL would return all of the UDP listeners, but 514 is not enabled. We need to enable it, and it's disabled by default for security reasons. So step B is to nano the etc sysconfig. Sysconfig is a repository for startup configuration files for daemons within Red Hat Enterprise Linux. And we'll modify the syslog file in etc, and this is the syslog config file, we mean the sysconfig syslog configuration file. We want to alter the syslog startup options to include -r. -r ensures that the service, when restarted, binds itself to UDP socket 514. So modify etc sysconfig syslog and include the -r option for the variable syslogd_options. So append or set syslogd options equal to -r as an option. And it's between double quotes, so let's just indicate as such. And then, of course, restart the syslog instance. Restart syslog and confirm UDP 514 listener. If we don't follow these steps, or if we don't enable UDP 514, we will be unable to log from across the wire. So we'll turn on -r, then exit. The M0 ensures marked messages are turned off so they don't appear in the logs. And then we will execute service, and service is a facility provided by Red Hat to ensure that you can manage your services, starting them, stopping them, restarting them, and so on. And we'll execute syslog, restart. Again, no need to memorize the service name. If you take a look at etc in init.d, where the initialization script resides, syslog, this is the name of the service that you pass in to the service command. So service syslog restarts the service. Now let's re-execute netstat NUL. We will find that port 514 is available. We can grep it out to suppress the output, and there you see 514. And if we turn on option P with the netstat command, you'll see that syslogd with process ID 6202 is responsible for 514. So now syslog will accept messages from remote devices or remote syslog capable clients, whether devices, other operating systems, what have you. So the next step, now that we've confirmed it, and we'll just list this as C1, confirm using netstat NUL grep 514, and it should return the syslog listener. The next step is to configure the router. So step D, configure the router, which means we'll need to SSH into it and enable the appropriate level. Now we know local 0 through 6 are available. We need to pick one, perhaps local 0. Configure the router using facility local 0 and level info so that we get a lot of information. Then step E will be to configure syslog.conf, that's etc syslog.conf, to accept local 0.info or local 0.star, and to route that information to an appropriate file such as Cisco router.log or whatever suits your environment. So with that said, let's connect to the default gateway from one of our free windows. Let's SSH as myself to the following address. We'll have to accept the public key. And now it lets us in. Let's show run include log or show log. Either or will reveal the logging settings. And we see that logging is currently configured to an IP address of .175. The facility is proper, and the trap level is set to warnings. We'll have to change it to informational to get more information. So let's config T, logging facility, local 0, that's set, so we'll set logging monitor. And if you log in question, you'll see different items. You can log in trap. We'll set it to info. And then we'll set the IP address of the logging host to 192.168.75. In this case, for our remote system, 199. We'll return to the main area and show run include log again, where we'll see that we've now set the host to 199, but we should also remove the other host. So let's config T, because the router will attempt to log to the other host, and we'll just indicate a no logging host 175. And again, logging help will return the various useful information. You can also set the terminal line logging if you'd like. So with that said, we should be able to log to our local system. And we can confirm just by show run include log or show log, either or will show the logging information. And you'll see the level for the different areas. The router has the ability to log to the console, the monitor, to the buffer, which is memory, and to various destinations. Let's write memory to save the changes, and then update the remote system's configuration by modifying etc syslog.conf. Towards the bottom, we'll include a comment, and it's going to be for local 0.star. .star will accept any level, whether it's warning, info, debug, critical emergency, so on. And we'll tab all the way over just to keep it consistent and send the file to varlog cisco-router.log. And be sure to bring everything onto one line. We'll exit to save the changes, and we have to restart the syslog daemon. Reload would also work. Restart or reload syslog, using, of course, service syslog restart. So let's go ahead and give that a try. Service syslog restart. Don't worry about creating the log file. Syslog will take care of that for you once it's received data from the logging source. So with that said, let's confirm as such by lsltring varlog, and there's the Cisco router log file. It's currently empty, however. We need to generate activity in order to see it. And again, just confirm the logging settings. Show run include log, for example. Ensure that your Cisco router is logging using the appropriate timestamp for your zone and other information. So the offset from GMT, timestamp representation, the precision of the time, so on and so forth. So we're logging to 199. Local 0 is our facility. Our logging trap will be info. And for other facilities like monitor, we can also set the monitor level to be informational so we get more information. Again, you see the 8 supported levels of syslog even with the Cisco configuration. If you configure an emergency, for example, it's set to 0, which is the reverse of the way it's represented in Linux and Unix. Debugging is set to 7. Nonetheless, the concept is still the same. The lower the level, or the more information it produces, the higher level of verbosity will create more information, not necessarily more critical information, but will create more log file information. An ideal level for a router is informational or notifications. But if you see that you're getting too much information, then consider perhaps warnings, or even emergencies if you don't want too much information from your router. Now there's one other thing you should note, and that is the IP tables software is turned on, which will prevent the receipt of some of the messages. But the file is created, but it will remain at 0 bytes until we have either disabled or inserted a rule. So look, the LSLTR shows it's 0, but IP tables -L shows the input chain contains rules blocking the traffic. So for example, if we were to temporarily flush or accept the UDP traffic, we'd get the information. So let's IP tables, and we're going to insert at line number 1 into the input chain, or we could append, either or would work, towards the end of the chain, because everything else will be dropped by the last rule for ICMP and for other traffic anyway. So if we squeezed it in or flushed the tables, we'd be able to see information in the log file. Let's go ahead and just flush it. Now let's IP tables list. We'll flush again, or in fact, let's just look at it again. Sometimes it takes a second, and now it's clean. So we'll receive information momentarily into our var log, Syslog log file. Now let's take a look again. Now we finally got some data. So less of the Syslog router.log file reveals information regarding the fact that the router is configured. And over time this file will grow, so throughout our studies, just like with other things, we'll check in to see what other useful information it's picked up. So again, just to quickly recap, Syslog accepts facilities and levels. It accepts wildcards such as .none, as well as asterisk. It also allows you to combine multiple facilities. You can indicate a target, such as a file, a TTY, a remote host. On the right-hand side, there are some free facilities for you to route information to, such as locals 0 through 7, -7 since it's used for the boot.log, and it's really customizable. Now we're going to be looking at log rotation next to show you how the log files are managed so that they don't get out of control or out of hand or become terribly difficult to manage because of their size.